Hi folks, we're going to take a look at number 15 on page 433 from the Unit 4 assignment. So situation here is you've got someone in a plane that's looking at a jet which is directly above an airport. Okay, and they give us the distances, the direct distances from the plane to the jet, the plane to the airport, and then they give us information about angles of elevation and angles of depression. So they say the angle of elevation from the plane towards the jet is 14 degrees, and the angle of depression from the plane to the airport is 38 degrees. So first thing I'm going to do is draw myself a little horizontal from the position of the plane. All right, because that's how we always measure angle of elevation depression, and we know that this angle here to the jet will be 14, and this angle down towards the airport is going to be 38. Okay, so that's just by our definition of angle of elevation depression. So we want to determine the altitude of each aircraft. So clearly the altitude of the jet from the airport is just going to be this side length of that large triangle, and the altitude of the plane, what we realize, is the same as this side length from this smaller and right angle triangle. Okay, so a couple of ways we can solve this, because you can actually work with these two right angle triangles, because for each you know a side length, you know an angle, and you know a side length in each of those. All right, so I could use primary trig ratios to find the height of the plane, and then use another primary trig ratio to find this missing bit, and then add it to find the height of the jet. Okay, the other option is to find this distance directly for the jet, which would be part of this larger triangle. So I'm going to use that scenario, since I just have to do one calculation. Might be a little longer, but it's a good practice of our sine and cosine laws. So first thing is to determine if I want to find the height of the jet here, which I'll call, J, use lowercase. I notice here that I do not know an angle opposite side pair. So it means I have to use cosine law. And of course, I'm going to use the total angle here, 38, 48, 52. So 52 degrees for the angle inside that big triangle. And so now I can just solve for this side here. So I'll call that J. Now we know the formula has J squared equal, but if I want to solve for J, I'm going to have to take a square root of all that. So if you're comfortable going to this step right away, you certainly can. Just make sure you don't make any mistakes. All right. So how does cosine law work? Well, it's the sum of the squares of the other two sides. So 12 squared plus 16 squared minus 2 times the other two sides. So 12 and 16 times the cosine of the angle opposite the side length I'm looking for, which we found was 52 degrees. Okay, so actually not so bad. Once you know these laws really well, they're actually not that long to use. So let's calculate that here. So square root of 12 squared plus 16 squared minus 2 times 12 times 16 times cos of 52. And we end up with 12.8 or 12.79 if we keep 2 decimal places. Okay, and I believe everything here is given in kilometers. Yes, it is. So 12.79 kilometers. Sorry, I'm not sure. I guess I said the 79 again. Sorry, kilometers, and we don't need this here. All right, so now let's determine the height of the plane. But remember, we said the height of the plane was just this side length here, which is in the right angle triangle. Now, because this is in a right angle triangle, we do not need to use sine or cosine law. In fact, I'm insisting that we use the primary trig ratios. So we have this angle of 38. We're looking for the opposite side. We know the hypotenuse, so I'm going to use sine. So we have sine of 38 degrees is equal to the opposite side, which is P, divided by hypotenuse, which is 16, and so P is just equal to 16 sine 38, and so that's equal to 16 times sine of 38, and that's equal to 9.85. All right, so let's do a quick recap of this question. So number one was to include the extra information that was given in the diagram, in particular using our knowledge of angle of elevation and angle of depression to include the 14 and 38 degrees. Then from there to come up with a strategy, and we saw that we had a few options, all right? I chose to go with the one that used the cosine law to find this whole side length, which gave me the height of the jet. And then the height of the plane was inside of this right angle triangle. So I worked with a primary trig ratio. Okay, that's it for this one.